Hello everyone, and thank you for coming to our webinar. I'm Eduardo Ramos, and he's Borja Gracia, and we are the founders of Capillary.io. As you may know, Capillary.io is an artificial intelligence system for capillaroscopy, and it's also a software platform for everything related to capillaroscopy. So in this talk, what we are going to do is we will do a sample capillaroscopy procedure, complete procedure, and we will show how it's done and how to use the tool, and share tips for using it and all the tricks. And you can ask any questions in the YouTube chat at any moment, and we will answer all questions at the end. We are going now to play a video of the capillaroscopy. The purpose of this talk is to describe how to do a capillaroscopy through Capillary.io. Basically, Capillary.io is an artificial intelligence system that will allow us to help or assist us in interpreting the capillaroscopy, so that we can analyze it quantitatively, observing all the data and analyzing each of the capillaries on the images. First of all, we are going to follow or try to emulate the steps that we take when we are doing a capillaroscopy, and what steps we have to take to use Capillary.io. The first thing we will need is to create a user account on the website. It is free to access, allowing us to upload up to 10 images per month for free. Once we have our account, we can create new projects which will allow us to collaborate at the hospital level, individual level, or any other level we need, and be able to coordinate with other users in the system. Capillary.io platform consists of two parts, a web application and a desktop application, which makes it possible for any type of USB capillaroscope to be used with it. See the microscope camera and later send the pictures to the web application so that it can be automatically analyzed while containing all the necessary metadata that will allow the automatic analysis of each of the images per finger and finger sector. What we are going to see now is how to do a capillaroscopy. You can see that there are different systems, different devices for capillaroscopy. You can use the G-scope, Inspectis, Dynolite. Normally, all of them have 200x magnification, since that's the standard magnifications for a capillaroscopy, and that's what Capillary.io expects. Even if your capillaroscope is not automatically calibrated, Capillary also has the option of manually calibrating your device. That's a little more advanced, and we are not going to cover it in this video tutorial, but later we can comment on it in the questions. Calibration is important, so later the distance measurements are precise and capillaries can be measured correctly. This is how we are going to do a capillaroscopy. An important detail, although very easy, is that first of all, the first thing we have to do when we want to use the Capillary app is that we have to connect the video capillaroscope before starting the applications, so it can be correctly recognized. In this example, we are using the G-scope for the capillaroscopy, and we see that the light turns on when we connect the system, and the software automatically recognizes the capillaroscope. As we commented, the Capillary app is only a viewer that will recognize any capillaroscope and help us to take pictures with complete metadata for later upload to Capillary.io. You don't need to use this app, but it's especially designed for taking photos of capillaroscopies, so it's a good app to do it in a standard way with any device. The app has some settings on the top right corner that you can see here, where we can configure the preferences, such as the sectors that we are going to take photos of for each finger, and we can adjust them. One important aspect to take into account is that the ABCD sector is designed only for panoramic photos at very low magnification in some devices that allow it, like 50x magnification in the Dynolight. Panoramic images are not analyzed by the software and should only be used as a complementary reference. A, B, C, and D are the sectors that we are going to take pictures of at 200x magnification and making the whole of the fingers. As you can read in these studies and other studies, is the standard way to do capillaroscopy. When we start the capillaroscopy, the first thing we have to do is to put the immersion oil. There are many techniques and types of oil, and that will depend a lot on the capillaroscope that we are using. For example, as a personal preference, I put oil on all the fingers first, and later, if necessary, I will add more oil on each of the fingers. Once we have done this, we can start doing the first analysis of the first finger. In this case, as you can see here on the left, we are going to do L2 and the first field, the field A. What I do is I go to the central part of the finger where it's much easier to focus, and this also depends on the type of capillaroscope that we use. For example, the G-scope has automatic focus button, so that when in the middle area, once focused in the middle area, we at all times have to try to see the entire cuticle, since that's where we are going to find hemorrhages, the first capillary line, and if possible, part of the nail. In this, for example, you can see that, and once I'm focused, I go to the border of the nail fold, but you have to be very careful not to go too much to the border, or otherwise the capillaries will become horizontal and difficult the visualization of capillaries, so you need to make them show perpendicular to the nail fold. Once prepared, we can take the first photo. The app allows us to use the physical button in the device, but also the space key, the F4 key, or even a USB pedal. When taking a photo, the system will automatically advance to the next sector, so that we don't have to click on the next sector or finger manually, and that makes it easier to take the photos. If we want to repeat a photo, we can go back to the previous sector, remove that, and do the photo again. When taking next photos, we go a little more towards the inner area, the middle area, and the last field. And as you can see, when we take the last picture of the finger, it will automatically advance to the next finger. When doing the capillaroscopy, you have to be looking out for possible bubbles or reflections that might difficult the visibility of the capillaries, and in that case, apply more immersion oil. Once the oil is applied, you can see that the capillaries are visible again without problems. There is not a standard technique for holding the capillaroscope, but my personal preference is to hold it with both hands, and one hand is for moving the capillaroscope and the other for making it stable so the pictures are in focus and not moved, and that helps me get good pictures. Also, one technique that helps to find the capillaries is to move a little back to the inner part of the finger, and then go back up again and focus on the capillaries and see them correctly. Some people might be tempted to take just one picture or two of the nail fold, but our recommendation is to take these 4 pictures, as that will be a better representation of the whole nail fold, and the quantitative metrics can be more reliable. Since we will be using artificial intelligence to analyze the pictures for us, it will save us a lot of time, and it's not a problem to have too many pictures that will take too much time manually. Again, here you can see that I'm using both hands to take the pictures. We can keep the capillaroscope stable with the first hand and take pictures with the device button, and with the other hand you can move the capillaroscope. All popular capillaroscopes are supported by the app, so it will work with the capture button in any of them and automatically detect their calibration, so you don't have to manually calibrate them. Here we just continue with the next finger, the last finger of the first hand, and we do the same process starting on the border and then going to the other border, taking the 4 pictures. Sometimes we can find reflections or bubbles that do not affect the visibility of capillaries, and in that case it's okay for us to keep the pictures as they are, because the analysis will work fine. Next, we will do the same process for the second hand, and of course the first thing to apply is the immersion oil. I like this oil because it's somewhat dense and it will be on the finger for some time, so I don't have to reapply the oil that often and be able to take the pictures in a faster way. For this second hand we will do the same process, so we are going to watch it in fast forward. You still will be able to see each picture. And while we watch this, I would like to talk to you about the papers that we published that explain and validate our system. In the first paper we explain what the models we built and how they detect, classify and measure capillaries and hemorrhages. And in the second paper we compare the algorithm results against medical experts in capillaroscopy and achieve good accuracy against their consensus. Once we have finished the whole capillaroscopy, and as you can see we have all the photos for all the fingers and sectors prepared, next step is to save the capillaroscopy. Right on the upper corner you can see a big button to save the capillaroscopy, and that will allow to save the photos to the hard disk of the computer and also do direct upload to the Capillary I/O platform for convenience. Whether we do one or the other option, the photos are always saved in the disk of the computer for later use, or if maybe we want to upload the pictures later, we still can use the web application and just drag and drop the images on their places, and that will always work the same. In this case we are going to do a direct upload to Capillary I/O, and once we click on the button you can see a form where we can input data such as the workspace where it will be saved, the project and folder. And this is important for collaboration because you can have many workspaces, one private to you, one shared with other people. Next we have to select or create a patient, and at all times we should use anonymous code for identifying the patients. We should never upload personal information to the system. Once we create or select a patient, the capillaroscopy will be given a name that can be useful to include information about why this capillaroscopy was done and include the date. So finally we clicked on the upload button and it has been uploaded, and the application will automatically open the capillaroscopy in our web application in your preferred browser. And the first thing we will see is a summary of the capillaroscopy with all the images. For example, we can see the project where it was uploaded, the patient was kept, the time when it was done. We can make changes to it. We also can see the pattern, capillaroscopic pattern. And at the moment the system does not suggest a pattern, but we will soon release a new version that will automatically use the quantitative metrics to suggest a pattern. Now, in each finger, we can navigate the images by clicking on the sector where there are images. In this case, we have images for all sectors except for panoramic. And as you can see, we navigate the images. We can see the annotations that were automatically produced by the system. And there will be some help text, but let's go to a detailed view where we can zoom as much as we want in the images and see them larger. There is color codes for identifying each capillary. So for example, a blue capillary means it's normal, pink means it's a tortuosity, red is enlarged, and as you can see, most of the capillaries are measured by the system. The system will try to produce automatic measurements of the apical diameter, the venous limb, and the arterial limb. And again, it will use a color code to show them. We can make as much zoom as we need. We can move the image, and in that case it suggested an hemorrhage with a different darker red color. On the right we have tools for modifying the automatic annotations that the artificial intelligence created for us. So there is a tool for adding new annotations, for example creating a capillary that was missing. We just drag a box and select the type. Then there is a second tool for modification of the annotations. We can change their size, their shape, and edit their type of annotation. And then there is the trash button for removing annotations that probably are wrong or we created by accident. Now we are creating an extra capillary. We are going to modify that box and change to enlarged capillary. As you can see, the color changed, and now we remove it. We must make sure to save them if we want, so they are kept. Finally, there is a measurement tool that allows us to make any measurement where we want, and also measurements can have types. Now we are going to measure a capillary that the system was not able to correctly measure. First we do them 3 measurements, and now they are done. We are going to assign their type. First the apical diameter, now the arterial limb, and the venous limb. And of course save the new annotations. Now we are seeing another image where the system missed a little hemorrhage, so it's very easy to add it and save. And here we are adding another hemorrhage. The system was able to detect the presence of hemorrhages, but did not create boxes for all of them. We save and review all the images. Once we have reviewed all the images, we should go to generate a report with the big red button, and this will show a form where we can input several medical variables for the patient. All of them are optional, but of course having them will help us in the future to carry out studies. Also, all the information that we input here when we download the report will be present in the template. All these fields can be customized with the help of support team at Capillary.io. So here we fill out some information. And finally click on download. This will save the information and download the document. It will contain all the information we have added and a very useful table with the quantitative metrics in a summarized way. And for example, here we can read there is an approximate 7.2 total capillaries per millimeter. And below you can see we have analyzed 68 millimeters, which is a lot of information compared to typical capillaroscopies where maybe 8 millimeters are analyzed by hand. This is much better and much more representative, and of course more objective. Other metrics we can see is that there is an approximate 40% of enlarged capillaries. That would be capillaries with an apical diameter of more than 20 microns. Still, the average apical diameter in these enlarged capillaries is 23.6, which is very close to normality, and probably this criteria will change in the future and consider capillaries up to 25 as normal. Other things we can see is that there are no megacapillaries. There are some hemorrhages, 17, with a approximate 0.2 hemorrhages per millimeter. We can also see average apical diameter, arterial limb width and venous limb width for all types of capillaries and their percents. These quantitative metrics are now only in this report, but in future versions they will be available as a summary and per image in the web application, so you don't have to go download the report to see them, and that will also go help locate interesting findings in the capillaroscopy. Thank you for watching this webinar, and don't hesitate to ask any questions you may have. Yeah, hello everyone, and thanks for viewing the video presentation, and now we are going to answer your questions. So thank you, Scott, for your 3 questions. They are actually very good questions, and I will now read this and try to answer you with the best answer I can give. So can the software distinguish between dirt and hemorrhages? So the answer would be yes. We have trained the model to detect hemorrhages which have the specific shape and aspect of a broken capillary, in this case a microhemorrhage. But sometimes they can be confused between dirt. Of course, no artificial intelligence system is perfect, but we are also continuously improving the system, the algorithm, so it will make less mistakes over time. But at the moment it's quite good at detecting the hemorrhages without errors. And also another question is, when measurements are important, it seems like a good idea to avoid manually calling capillaries, because if the software is unable to call the capillary, measurement probably won't be accurate. So measurement is very important, but actually in the first paper that we published, you can find this in our website, what we have is like a flow of different models, a workflow, where there is first one model that classifies the detected capillaries by their shape, so that can actually detect that it's a ramification or tortuosity. But also there is an extra model that tries to detect the size of the capillary, even if it has not been measured yet. And it's quite good at detecting the for example, enlarged capillaries, only based on their size, their aspect on the image. But of course, then if the capillary can be correctly measured, then the measurement is used for a more objective classification. Also, so you call hemorrhages based not on the volume of blood coming out, but areas where the blood has condensed and look darker. Yes, so here the terminology we are using is the microhemorrhage, which is normally like a broken capillary where the blood has coming out of the capillary, and they have a specific aspect. Sometimes they are like piled up one above the other, and like coins, as you may know. And also, can you please explain what a ramification artifact is? So ramification was the classic way of saying abnormal capillaries, where they take forms, a very strange shape, an abnormal shape, which is the new terminology. So you can find these ramifications as abnormal shapes in the current papers published regarding capillaroscopy. And these ramifications are sometimes capillaries that have like many branches, or shapes that are completely disorganized and not looking like a normal capillary with the typical form. And yeah, I think those are the questions. I don't know if anyone has any further question. Also, we recommend you to read, if you're interested in the technical details, the two papers that we publish in our publications, part of the website. And we are also working on new research for detecting the capillaroscopic patterns using the quantitative metrics that we produce, so we can give an objective capillaroscopic pattern. So is it difficult to distinguish between ramifications and angiogenesis? I think they are mostly the same. I might be mistaken, because I'm the computer science engineer. I did the system, and Borja is the medical doctor, expert in autoimmune diseases.
Is the last term. Now we say angiogenesis.
Yeah, so neoangiogenesis is the new term to refer to ramifications, and yeah, most of the time ramifications is no longer used, and you can call them abnormal shapes or neoangiogenesis. Maybe this is misleading in the text that was shown in the presentation, but it can be updated. Yeah, no problem. Thank you, Scott. And yeah, later we will do this same webinar in Spanish in 1 hour or so. So if anyone prefers Spanish, you can join. And this will be in YouTube to watch as many times as you want, recorded. So yeah, thank you everyone.